Okay, so the question is the lead code number 112 paths from there. So what is the given in the question here? So there is a binary given here, and there is a one target sum given here, and we have to see if there is a tree in each, if it is has a root to leaf path such that adding up the values along the path equals to target sum, we have to return true. Otherwise, if we are not able to find any of the path here, we have to return simply false there. Okay, so like it is a very simple typical binary equation. So what we simply pass, we simply traverse our DFS from the root to leaf path, and in the when we reach to the leaf path, leaf node, we have to check whether till here the sum is equal to target value or not. If it reach, so we return true, and correspondingly false there. So check this. So I explain try running for this path. Okay, so we see there, first of all, what are the things we have to pass for the DFS, see, wait a second here. Okay, so when we are reaching to any okay, there, this is a current node there. Okay, so when we have to call for the DFS of any particular node, so we also have to pass the current sum over here to track the all of the sum till that node there, from that goes or that coming from the upper nodes there. Okay, so now first of all we simply use any kind of the traversal here, for example we use a post rotor traversal here. Okay, so we call for the DFS for this root node. It calls for its left. Now it calls for its left, it calls for its left, and it calls for its left. So let's say this is the sum there. Okay, let's revamping this. Okay, so first of all, what is the sum value here? So since the sum is equal to update becomes sum becomes 5 there. Okay, so when it calls for its left tree or its left child, what is the sum to here? So here sum become 9 there. Okay, now for this node the sum become 20 there. Okay, now here the sum become 27 there. Okay, now we check, since we reach to the leaf node, we check since this sum is equal to leaf node. Now no, because the leaf node, the target sum is that we are supposed to see, that is 22, but here 27. So what it means, it simply returns the false there. Okay, so it simply returns the false here. Okay, so okay, so go for this node. So since it check for its left child, so now it go for the right child there. So here the sum is equal to, so here sum is equal to 22 there. Okay, so this is the desired target value, means we reach our targeted value, so that means it returns simply true there. Okay, so it returns its value true there. Now if we stand at the 11 node, since it see it get the targeted some value from its right child, so it doesn't matter whether it is gained from the left or not, or right from right or not, since it is get, so since we have to return simply true or false. So in case of the any of the cases it get from the left or right, it simply return the what are the or of this, so it return the true value here. Now it for the false also, since it get true from its below part, so it simply return the true for its parent here. Similarly 5 goes to the right, this right subtree there, then it goes to 13, then it goes to 4, then 4, then it return, but it not need to go like it not need to check for the all of the dry run here. We simply see when it gets any of the true from its any of the child here, which simply return the true value here. So this is the true answer here. So coming to the code, this is the very explaining part here. So this is our main function here. First of all we have to call for the DFS for this is the root node, this is the 5 node there, and this is the current sum there, so that is 0, and this is our targeted value there. Now this is our DFS part, this function written here. So this is a bool function here, DFS of node and node sum and the target value. We simply use this is the base case here also. In case of when we go to any of the node that is a null, since there's a node is equal to 0 also inclusive there, so in that case the test case number 3, this doesn't false, so it simply return to a false there. Okay, so like first of all DFS calls for 5, then it calls for 4, then it calls for 11, then it calls for 7, then it goes to its left. So here's the null, so it return the false value here. Similarly it go to the right child, since it also null, so it return false. So from the left and from the right it gain the false there, so it return false to 11. So similarly it goes to true, but here the sum become 22, so means it return the value true. So for 11, if it get from the false there and true from there, so it means it find at least one path there, so it doesn't matter what are the value of the left or what are the right, it simply return the true value there. Okay, so like when we reach to the any of the particular node there, it simply first of all update its value, the sum plus is equal to node value. And now we have to check if we have to reach for the any of the leaf node there, we have checked if sum is equal to target, it return true value there. And okay, and simply since this is a bool function there, so what it return true false there, as it calls for its left part there and it calls for its right part there, and whatever the result from the left or whatever the result from the right, it simply use the or wise operation of this, and that it returns to the its upper node there. So like this is the code there. So what's the time complexity is there? Simply first of all we we have to call from this top to bottom here, but it simply return the value, so only one pass of the recursion is one pass of the flow is going through here, so simply time complexity is become off and there. And what is the space complexity here? So we don't use any of the extra space there, this is there is only the recursive space only there. So like how to find these space or in these three questions there, so we have to go general, we have to go for the worst case there. So what is the worst case there, like what is the measurable space complexity in these three questions there? So when we talk about any of the skew tree, what is the skew tree means, it is flow in the one direction there, so it's simply written so what its height there, it is simply is nothing, is it's simply off edge, so that is its space complexity, means I mean to say. So what is the time complexity is here, it is off and there. And what is the space complexity here, it is of simply h there, but this is the simply height of the tree, like this, there's a, in this case is the 4, so this is off over there, this is the off and there. And since this is a optimal also, so there's no need to optimize this any further, so this is the question there.